everyone. I think we are live. So welcome back. Just give me a second. It should be fine. Hi Nidhi. Good morning, Anand. So as it is clear, today we will be actually attempting a case study. So yeah, let us wait for 5 minutes around for others to join. Meanwhile, do let me know if my voice is clear. Overall, like the whatever I am writing, that should also be clear. So yeah. Come back. So just confirm to me once, everyone, if like the voice is clear as well as overall the full technical setup. Like you're able to see what I'm writing, everything is clear, the brightness and everything is basically top notch, so that we are good to begin and don't face any issue while we are in the session. Okay. Thanks a lot, Praveen. Thanks, Anand. So today is gonna, of course, be a very interesting session. We would actually be attempting a real life case study which will actually give you an idea about what all we studied, as well as the good thing which I have been mentioning from the very start. We will see that why EDA, or let's say feature engineering, plays a very critical role. So when, let's say, one is doing or understanding some data, if you will remember, I start like in the very first session of introduction to machine learning, I said that how business understanding, domain knowledge, these all play a very high role. So today we will see the same in action. Okay. Let us just wait 2 more minutes and then I think we should be good to begin. Meanwhile, if anyone has any doubt, please feel free to ask them in the comment section, like regarding anything or let's say any previous session which we took. Just let me know in the comment section if any doubts are there. All good. Okay, so I see people are still joining, so let us wait 1 more minute. Meanwhile, everyone, please feel free to let me know if any issues are there, like any doubt, anything. Would be glad to take that up. Praveen, today for this community session will be the last class. I am actually thinking of starting another community session next week, most probably, in which I intend to cover either Python, data science, or let's say you guys can know me. Let me know today if anything is there. Or else, let's say we will be doing this case study today. Hopefully, we should be able to complete that. Like I've kept that in the same way. Okay. If not, or let's say if another case study, you guys enjoy this and you want another case study, maybe we can connect tomorrow again. But for this machine learning foundation community class, this this should be the last class. The reason is that we have covered few of the algorithms, the entry level, so that you have a good base where you understand a lot of things, and other algorithms now you can cover, because linear logistic, decision tree, and nearby, these are kind of, I would say, algorithm which are the foundation algorithm of machine learning. Okay, so for example, if you tomorrow study about random forest, that is just basically a lot of decision trees and how that happens. If you will try to understand random forest, because now you know decision tree, random forest should be easy, very easy to understand. Okay, on that note, basically any ensemble techniques like grad boost, rada boost, all these algorithms should be clear to you. Same goes for if someone wants to sharpen, let's say, neural networks, or basically, let's say, some probability based algorithm, then these linear regression, logistic regression, as well as the naive base should be a good, I would say, base for that. So that is what I intended to actually cover in this particular series, where someone has a now a foundation foundational idea, the maths, how things happen behind the curtain, all these things, and then able to, of course, actually also use that. So if all these things are now clear, we will make sure now to basically, yeah, we will have another community session for sure, but yeah, today for this foundation thing, this will be done. Thomas is saying NLP DL unsupervised learning. Okay, Thomas, do you want me to take classes on this? I can actually take that. That should be fine. But we can have a community session, let's say, for a week or 2 weeks where I'm covering concept related to these things. Should be very easily doable. So I see people are still joining. So just I'm giving 1 more minute. Okay, then we will actually begin. Meanwhile, everyone, just please confirm me once again about the voice and everything. So actually, we will go back to screen. Actually, I was checking this. So yeah, if everything is fine there, I think we should be good to begin. Sure, Thomas. So actually, I think what I have in mind is what we can do maybe is that let's say we have a class where we start from Python or data science. This is basically because I give a lot of importance. I know from industry. So what happens is when people are studying, they don't give a lot of importance to data science concepts. Okay, for example, basically how to handle missing values, outliers, and today also we will see how to do univariate, bivariate analysis, and other things on data. Okay, once I think we can maybe start with that, then I think yeah we should be very good to start with even so unsupervised algorithms, NLP, DL. So unsupervised we have KNN algorithm, hierarchical clustering, all these algorithms, and NLP basically is a completely I would say independent kind of a branch. The problem which we face in NLP we are actually pretty I would say different than how we face ML, like how we go about ML algorithms and ML problems. Okay, and then deep learning, of course, handling images and everything that is very good. I have actually so my research paper is actually in the field of deep learning only, where we use a CNN and LSTM based model. So have a very good idea on those things also. So can do that, Thomas. Should be fine. I will create a plan and basically have that. So yeah, everyone should be hopefully like gain benefit from that. Okay. So anyone, if any other things are there, let me know. Okay, then I think we are because now starting, so should be good to begin. Yeah, so leave all your comments in the comment section. Any doubt or anything? So we will now start with today's session. A lot of people would be there for the very first time. So what actually I intend to do is first quickly cover about this whole community session and everything. So if you will see on my screen, this is the ineuron website. Okay, so yeah, basically a lot of courses are there. We have to go to explore courses here. Okay, ineuron.ai is the website. Then you can actually go to either you can search community classes. You can check out our other courses as well. I suggest to go on my name and then see all the I would say courses which I'm taking. I intend to take a course on machine learning and basically full stack data science with Gen AI as well. Okay, so these of course also we will be doing. For the current session, like we are basically in this community machine learning foundation community class, which you can go and enroll. So even if someone is joining today's class, it should be fine. Okay, one can actually go here. Now you will see all the previous classes here. So all the previous classes which we have done are present here along with assignment and quizzes. Will actually suggest that yeah, do all the assignment and quizzes. If you enroll here, okay, and complete the same, you should be able to help you with a certificate. So that certificate will be actually useful to you to show, or let's say normally also that yeah, to add on LinkedIn or anywhere that yeah, you are basically aware of machine learning foundations. Mohammed Azkar, how do we use PCA, LD, and TSNE? Mohammed, that's a lot of good algorithm. PCA, I can maybe give you a quick idea, but so I won't be. I don't like covering algorithm. Let's say in a very small bit. Okay, PCA, a lot of maths goes into that. If you have taken my sessions, you will know that I am very much like I basically like to tackle algorithm completely like to understand them from scratch and towards the end. Okay, so PC actually is not an algorithm; it's a technique where we can reduce the dimensionality of our data. Okay, so these kind of basically techniques is what I was just discussing. That maybe yeah, we can have some sessions where I can discuss on that, but we will actually be going into these techniques and everything from proper, I would say, maths and proper understanding that okay, how and why should they can be done. Okay, so sure, you can have actually these things. Is there any deadline for assignments? Praveen, I'm actually not sure, but I don't think there should be. I think if you enroll from ID and basically then start, you should be able to complete that. I don't guess there should be a deadline. So can confirm that from the team. But yeah, I don't think there should be a deadline. But ideally, it should not take you more than let's say a week to complete if you are basically doing this at home. Okay. So I think okay, this started again. I'm on 2x. 1 second. Yeah. Cool. So yeah, this was all how you can basically go on iNeuron website and start this thing. The same actually is available on YouTube. So one can actually go on iNeuron intelligence. Then you can go on live here. We are having our ML case study. 21 people are watching, and then yeah, you should be able to see that yeah, all the other classes which we have took. So we'll highly suggest to watch them. Decision tree, then decision tree metrics. This was a very good class. We discussed all the metrics and calculated them exactly. Very important from interview point of view. Okay, and then yeah, of course, other algorithm, naive based, then logistic, linear. All these are done with very, I would say, support to maths. So should be, I think, doable very easily. And I would actually suggest so that everyone can basically do the same. Okay, do check out our other community classes as well. That should be helpful. Now let us go. So this is actually okay. One thing I want to just quickly understand from the audience: how many people are like comfortable with what I have open in my screen? Like this is a Jupyter lab. Like it's, I would say, a next not level, like an enhancement to Jupyter notebook. So I think most of the courses which we saw all are run in this only. Okay, so Jupyter notebook, just we can open one. This is like of a full interface where we have multiple things running. We can have multiple files. So how many people are basically aware of Python overall? Or do they have any issue, or do you want me to cover that okay how this is done or how we can start this based on the audience, like how much audience is comfortable? Okay, I will be happy to cover the same if someone wants it. If not, then I think we should be pretty good to start with. So let me know in the comments if any, like whatever actually I'm doing, you want me to give a quick I would say walkthrough before that. So Mohammed, are you comfortable with Python and everything, or do you want me to give a little bit I would say intro first? Let's say 5-10 minutes intro that what exactly is happening and what is this, all these things. Okay, let me ask one thing in the question. Do you want me to quickly cover Python basics? Yes. Okay. So just let me know if anyone has any issues. Meanwhile, let me quickly actually just see the product structure. So we are doing this project, hard stroke classification. This is actually a full app. You can create a new notebook here. Python kernel, we can select fine with Python. Cool. I think I see the people are comfortable with Python. So I think we should be then good to begin. We can just move away from this file. Okay. So the very first thing which I want all of you to basically understand is on this data. Okay. So actually, I think we should be good to see data here only. Yeah. Good. I was not aware that we can use the data. So yeah, this is a healthcare data set structure. Okay. So let us see quickly what all this data contain. So yeah, few things which I want all of you to understand and pay a lot of attention to. Though we have studied ML algorithms, okay, the way I'm doing to this case studies actually will be based on how exactly you should do a project when you are faced with that project in industry. Okay, so I know we have done a lot of machine learning in our course, okay, but I will actually be paying, I would say, equal amount of time, or rather more to basically data science part of it. Okay, algorithm application is pretty easy, honestly. Okay, you can see that we just have to import from sklearn in real life and apply that. Yes, we should be aware about hyper parameters, tuning, and all these things, but overall that is important. So I will actually be going towards this problem the way it is practice in industry. Okay, that is based on my experience of doing all like a lot of projects in basically my professional experience. Meanwhile, there are few things, okay, which I have kept. Those might which a lot of you might not be aware of. For example, I have used random forest algorithm. I have used ARA boost. Few of the plots will be a little difficult to understand. I will be sharing all the codes. Okay, but the understanding or the mindset is that I don't want you all to basically train in such a way. I don't want to, let's say, overfit all of you by training. So I don't want that you just learn what I'm telling you. Okay, you should be comfortable in exploring things on my own. That is my main motive with this course, or let's say with this case study as well. So if let's say you are able to construct simple graphs and everything, there will be few functions which might not be that obvious to you, but those are very easy to understand. Okay, easy to gain once you can just Google it and try to basically make some changes onto that. So we'll be sharing these files. Okay, spend a lot of time on understanding this. Spend a lot of time in seeing that, okay, how these graphs are made, what all we are doing, okay, how we are handling outliers, how basically imbalanced data or let's say missing values are handled. All these things are to be done. Okay, so I expect that once I share the code and case study with you, you will be spending a lot of time to understand. What you don't, you can reach out to me basically if you face any issue. Okay, but I expect that if you will spend the time, then it will be a good project for you to cover on your personal CV. Okay, so that is something which I expect. Of course, if anything is not a lot clear, you can basically join my future community session. Let me know. I will be very happy to take that. Okay, but we will be discussing that with respect to not an academic project, but an industry level project. Okay. Cool. So yeah, let us first quickly do the data analysis at our level. So delimiter basically it's a CSV file which is given to us. We can see that we have ID. Okay, so generally what happens is ID is not very useful. Like it is just some Jupyter Lab versus Jupyter Notebook for projects. Thomas, both of them works fine. Jupyter Lab, what I have seen is give you a lot of tabs like structure which we are now comfortable with. Jupyter Notebook you have to open different tab in browser. So both of them the work is completely the same. It's just they are just running like Python notebook files. So overall should be fine. I don't see any issues. Like it is just I would say the way we have to open different tabs and different Python notebook in different tabs. It just provides us that inbuilt in a single tab. Okay. So cool, yeah. We have IDs. Normally, ID you can think of, let's say, roll number in school. Okay, we will make sure that every of the example or everything is clear with a real life example. Gender, of course, can be male, female, others as well. Okay, then age of a person. Okay, then next are a little bit important, I would say, variables which is hypertension. So even let's say if I'm given any data in the industry, like let's say when I do a project in any professional job, honestly, when I get the data first day, I would actually not be even spending by doing anything else rather than just seeing the data. Okay, to understand okay what exactly data is saying. Is there anything which I can make sure of data? So for example, I see that okay, there is hypertension. Okay, so one very good basically we can actually see the target variable as well. This is so target variable is actually stroke. If you will see, okay, target variable is stroke. Okay, so I know that okay, he like the data has taken one of the data point is hypertension. Okay, so maybe what I can do is I can actually have some, I would say, metric, or I can just serve the rep to understand if there is any relation between hypertension and stroke. Okay, that's I would say very good research which you have to do. It is never the case that you are in a box when you're doing a project where all what you are given you have to just work on that. Few projects might be like that, but then also domain and outside knowledge is of course very helpful. Okay, so yeah, we have hypertension here. Similarly, we have heart disease. So very, I would say, understanding or insight would be that hypertension and heart disease should have a role to play in stroke. Okay, so for example, I think this should be one should be yes. Normally, that is how we do. We have to just see that it is not 102. Okay, it is a boolean. Okay, so we have to also make sure that normally what has happened is if data is very nicely prepared, someone has worked on data very well while before giving to you. Let's say you get the data from client or anything, then they also provide you a manual with that data. Okay, so you can actually read that docx manual and basically get sure that okay what field means what are the different kind of values in that field. If you have yourself instructed, then of course you have to do all these things and be, I would say, make sure that you are checking. So normally, for example, we can check the same also, but heart disease, this should be that yeah, person has a heart disease. This would mean that there are chances of getting a stroke is high. Then I think if we go a little forward, we have We have ever married. Okay, then we have work type. If it's provide, let's see what are all the government job, private. We will do univariate and other analysis as well. But let us first spend a little time on understanding the data. Okay. Then if I go a little forward, residence type is there, average glucose level. So average glucose level, I think should be something related to diabetes, I hope. Okay, so normally people who have more diabetes or let's say average glucose level are high, then the chances of getting a stroke is basically gets increased. Then one more thing to understand here is that yeah, our data does have NA. Okay, so we might have to see that okay how we can handle NAs. Normally two ways are there to handle the null values. They are actually either we will calculate them or we will basically remove the rows. So maybe we can remove this full row. Then this is the smoking status. Okay, BMI is given. BMI normally is I think if I remember it right, it is weight square upon height or something. We can see the formula. Okay, but it should give us a decent idea about okay if the person is overweight, underweight, malnourished. I think these were the few I would say categories. So we'll see on that also. Then smoking status and then the stroke. Okay, so this just seems like our data is actually pretty straightforward. Okay, we are able to make sense of a lot of variables, or rather all of the variables, and we even have an idea that okay what might be happening. For example, smoking status at a high weight, let's say average glucose level high, residence type, we will see if people in urban or rural area who have a high chances of getting a stroke. Okay, ideally I think it should be towards the urban side because of the habits, pollution and all these things, but we will see on that. And that depends a lot also from where the data is taken. Okay, then work type, ideally I think work type will also have a role to play, but we will see which kind of job kind of have that. And if we can actually make that, I would say overall inference from the data. Okay, so it might happen that this data is skewed. For example, 90% of people are doing a private job. Okay, so of course the number of people who are having heart attack in private will be high, but that for sure doesn't mean that it is basically telling into that thing that okay this is the reason stroke is there. Okay, so this thing we have to understand. Then ever married, we will actually see how that roles play a role. Then heart disease, hypertension, age, gender, and I think ID. Yeah. So these are all the fields. Anyone has any other insights or any input or any questions on the data? Okay, I think just have to should have done that. I hope this data is actually now more clear to you. Okay, let me know if it is not visible. Like normally in the camera, it requires a little bit of I would say zoom in. So anyone if has any other I would say problem or did they understand that okay how we just went about the data? Any other insights which they might have by seeing the data? I will just scroll again from the data. So we have the ID. Okay, you can think of that as a roll number or something. Then gender is there. Then age. Similarly, we have hypertension 0 and 1. So hopefully it should be 0 yes, 0 no 1 yes. Heart disease, ever married. Then work type. Okay, it is we were able to see that it's private, self-employed and government job. Maybe there are other values. We will see that also once we do univariate analysis. Then residence type, urban, rural seems to be the only value. Then average glucose level is there. Okay. Average glucose level, I said that okay, normally if average glucose level is high, person is suffering from diabetes, then that has a role to play. Then BMI is there, and we do have NA also in this. So we are sure that okay, we have missing values in our data set. We have to handle that. Okay, so that is a very first thought of I would say which will go into my mind. Then we have smoking status and stroke. This should be our target variable, dependent variable. Why? So in all our data we saw right that okay this is the data which is given to us. Although we took iris data and other thing as well. So this used to be y, this used to be x. Okay, here it is our categorical variable. So 0, 1, 0, 1, it can be yes or no, and other variables were given. So we saw this type of data in I would say naive-based decision tree classifier as well as logistic regression. Okay, where it was classification type of a problem. So can I get a quick yes if everything is clear till now? Quick yes and thumbs up would be helpful. If you guys have any other, I would say, observation in this data or anything which you would like me to explain a little bit more, just let me know. But yeah, this is the very first step. This is even actually, I would say, what I have even done. Message is redundant and feature more dependent on the ML algo. Thomas, we cannot, as of now, actually treat any variable as redundant. Okay, it might happen that, let's say, for example, people who are unmarried, we are seeing most of the, let's say, stroke cases in that, or let's say, marital status has a role to play. It is dependent on some other variable. Okay, so before saying any variable as redundant, okay, we should not actually be doing that. Honestly, in this whole, I just see ID as a redundant thing. Okay, if you remember, even if we would have a name, I would have kept that as an important variable, because it may happen that, let's say, person from a specific subcaste, or let's say something have their gene or something where the probability of heart rate increases. Okay, so there are a lot of I would say diseases which depends on your ancestry or your DNA and everything. Okay, so based on that, like let's say, normally, if I remember right, people in Indian subcontinent are actually more very much prone to diabetes. Okay, then that is not the case towards North Africa or Europe side. So these kind of inferences can even be made from the name. Yes, it will require data from outside, but yeah, as of now, I will not say that marriage status is redundant and feature important depend on the ML algo. That's not the case, Thomas. So actually, I also told you in the starting, right? It can depend. Our ML algo can get that feature importance. We have few algorithms, but in industry, or let's say what you're doing normally, right? First, make sense data of your end. Okay, first make sure that whatever you are doing to the data, you are able to understand it, because we also are a machine learning algorithm, which we saw in the introduction to ML, right? So just make sure that data, whatever you can add to the data, the way you can massage it, the way you can actually, I would say, work on the data, you do all that thing first. Then we will let ML algorithm work on that. You have to understand one thing: ML algorithm doesn't know exactly what hypertension it is, or let's say what particular age will have a role to play. Okay, it doesn't understand the full, I would say, scope of any variable. It just works on the patterns and everything, and then basically give us what we want. Okay, so this thing is very important to understand. Anyone who has any other questions or anything? Give me a quick thumbs up if everything is all right. You guys understand the data very correctly. This is the very first point. Tomorrow, if you go in any company, any startup, and if they provide you with the data, maybe this is the first step which you will have to do. Cool. If no doubts or anything are there, let us go to our code. Okay. Let me know if this is visible. I think hopefully this should be visible. Like in this Zoom setting, it should be visible. Let me know if this thing is not visible, everyone. Like if we have to collect anything here. Okay, I've zoomed in into the default which we see. So now, few libraries we are importing. Pandas as PD. Very, I would say, textbook library which we use to handle our data. Okay, we basically have our data in data frame format in this. Very similar to how we saw the data just now in this Excel, or let's say CSV format. That is what pandas help us to do, to work nicely on rows and column. NumPy as NP help us in basically, I would say these are the way we can handle arrays in Python. Okay, list normally is not that fast. List basically have it a heterogeneous where it can store different types, but arrays basically in NumPy help us to basically handle that. So that is the one thing. Then Seaborn as SNS. Seaborn is actually used as for, I would say, data visualization. Okay, if any library which you guys are not aware or have any doubt, just feel free to go on Google, okay, and see that, okay, for what that particular library is used. Okay, so if, for example, if I, let's say, go on Google and see that, okay, what Seaborn is. Okay, Seaborn Python. See, statistical data visualization is what it is showing me. So just by opening the library homepage, I can actually see that, yeah, this library must be getting used in, one second, this library must be getting used to make some data. And I can see that these are pretty, I would say, great graphs overall. Who's asking question? Muhammad is asking question. Which feature importance is more reliable? Linear model feature importance like MLR, ridge of, or tree model feature model, random forest? Mohammed, we will be applying both of them. It depends a lot on data. So let's say if your data is kind of in a linear side, the regularization which you are applying. Okay, so if I remember right, lasso algorithm was actually used for feature importance. Okay, ridge was used to basically avoid overfitting. Okay, those were the regularization parameters. Okay, but we will actually see by applying all of the algorithms. Okay, here the case is not that one versus rest. It is like, yeah, let us apply the things and we will see what is important. Where to find data set link? With Vineet, I will be sharing this data set along with all the code files and everything with you. We will actually be doing this case study together. Any changes which you even suggest me, we will be doing on the spot. I will be sharing and basically giving you all the things. Okay. Cool. So yeah, matplotlib similarly is used for all the visualization and everything. We import this as PLT, and then warnings, and basically yeah, we are just ignoring the warnings. Okay. Cool. Yeah. So quickly, we are now reading the data. df.read CSV is just a simple CSV function. Then df.head help us to give the top 5 rows of our data. Okay, head is the top 5 rows. So we just saw these data: age, hypertension. I normally prefer to just see the data via Excel if the data is basically open into that. Sometimes data is very large, or basically data is of the form where it doesn't make much sense on Excel. So we can actually just go and see that. So this is just our data preparation and basically simple understanding. Now next thing, okay, 1 second. I think I will have to run this all. So on that note, just cool. So let us run this one by one only. Yeah, df.head, we got all the info, and df.info is there. Okay, so let us quickly understand what it does. I would actually prefer to write the code, but normally in this setting, it is better to make you guys understand everything. But then writing the code becomes a little bit difficult. So that's why we will be just seeing the code. Okay, and I will be sharing these files with you. I hope this thing is completely visible to everyone. Okay. So df.info, if we will now see the same variables are there, but this is the D type is basically the object which Python has, I would say, I would say identified for that particular thing. For example, gender, it is identified as an object. Age is float 64. Ideally, age should be int. Hypertension, we saw that okay, this is 0 and 1. Okay, this is 0 and 1 heart disease, but it has actually, I would say, it has got that as a int 64 int object. Okay, so this is I think something which we will have to work upon. We have to maybe change this into categories somehow. We will see how we can do that. Okay, next is then ever married. Similarly, it has an object where I remember these were basically few values. Okay, so this data preparation we have to do for any project. Similarly, work type, it is object. Residence type, I remember it was urban and everything. Average glucose level seem to be a float only. Okay, but we will see if we can do anything on that. Sorry for that. BMI similarly was also a float. Yeah, BMI similarly was also a float. Smoking status, if I remember right, it was category. Okay, so we see that okay when actually reading this data, normally the way it happens, Python has made some mistakes. Okay, and that is expected also. Like as I said, any computer, any algorithm, it doesn't know that okay what exactly these values are. Okay, it is we who work on those values. That's why this understanding becomes important. Okay, so now if you will see a lot of variables here are basically wrongly, I would say, identified. All of the categorical variables are not identified correctly, as well as let's say hypertension and heart disease, they are 0, 1. Same goes for age, which is a float. Okay, so let's see inconsistencies in the data. So we are checking age unique. Okay, it is giving us all E plus 0, 1 is there. Okay, and it is 8. So we don't have an age where it is, let's say, 80.71. I don't remember seeing any age like this. Okay, so that's why what we will actually be doing is we have to convert this age into int. Okay, see, so what I'm doing here in this thing is that df age dot as type int. So in my variable I'm making this change, df age dot as type is equals to int. Okay, anyone, I just give me a quick thumbs up or yes if everything is clear till now. If you want me to include any other thing which you think might be important, we can write that code on the spot. Okay, or if you think like, let's say everything is clear to you, then we should be good to move forward. Just give me a quick yes or thumbs up. We are just doing a very basic preparation and understanding of the data as of now. This is exactly how even you will be doing if you get a project tomorrow in any industry. Okay, this thing will take a lot of your time. You have to but make sure that all the information which you are passing to your algorithm or let's say to your model, that is fine. Okay, or let's say not even in the model, but even let's say when you're doing this, I would say exploratory data analysis, ED on the data, you are making the graph, so those things should make sense. Cool, thanks, Mohammed. Now, yeah. So DF age unique, we will now actually be seeing the unique in the ages to understand and make sure that okay, they are not, I would say, towards the categorical side, or let's say their variables are not in that way. So if you will see now, yeah, this does seems better now. So we have age from let's say going from 4 82 to I think 81 is there. We can actually do describe also, but yeah, 82 is there. So yeah, this seems like the data is basically present for describe command. Yeah, Thomas, that is actually I was suggesting we can actually use that. Let me use that because now it has been suggested. Actually, I think I've used that in the last, but yeah, meanwhile, let us see that. So the problem is like a lot of data as of now it has identified as int only, but for the age specifically, yeah. So age we see minimum 0 and maximum is 82. 0, okay. Age 0 is also there. Nice. So not sure how we got the data for all the 0 thing. Like the person was just born, but yeah. No worries. So we can see that yeah, age is there. Describe as suggested by I think it was Thomas. Yeah, as suggested by Thomas. It helps us to basically get an overview idea of our data. So what describe does is you will see all the variables here. Okay, and you will see count, mean, medium, mode, and everything. One more thing which I would like to cover is that you will see that all our values are having 51110 basically count except BMI. So why the reason BMI is having this less is that if I just use red because it has NAs in it. Okay, so NAs is not basically counted in that. So that is one thing which one has to understand. Okay, BMI, that's the reason BMI is not having that, and I think only BMI has these NAs value. Okay, so removing all this quickly. Convert to category, of course. It helps us to now basically save memory. I just added these notes so that this will be helpful to you when you basically read that on your own. So gender, ever married, work type, residence status. Okay, we saw all these residence type and smoking status. So we are just now defined all these columns. Okay, now columns dot as type category. Okay, so that thing is very important to understand. Now if you will see the info, yeah. So now if you see info, my bad, sorry, yeah. We have the ID which is N64 which seems right. Gender now is category. Age is N64 seems right. Hypertension, heart disease we as of now have kept 01 only. Okay, then ever married, work type, residence, all these have been changed to category. Average glucose level and BMI are float only, and smoking status is also a category. The reason is that we are given these categories as the exact value. Okay, so maybe we can change it to 01 or 10. That thing is on us. But we have actually kept that as N64 only as of now. We know their category value, and other we have basically converted into category. Okay, so now of course the very next things to do is basically drop our ID column. We have seen that ID is not giving us any of that information. ID is just I would say an identifier for a particular person. So let us drop this ID column. And now actually if we do info again, we will be seeing ID has been dropped. And this is now we are saving to a new CSV file, clean straw. Okay, so this was a very basic level of I would say why convert to category from object D type. Thomas is asking why converting to category. Thomas, it is basically helpful if the object is of category side. It takes less memory, and our algorithm, or let's say whenever we applied any plotter or anything, they are able to understand that these are categorical variable. Okay, these are having some specific values. Okay, in what can happen is that if let's say while reading or anything, first thing is it can treat values as different. Okay, it can add some exponential or anything on that, and as well as this is a little bit heavy on memory. It makes sense if your variables are categorical, you just keep them categorical only. For example, in our work type, okay, I think it was read as object if I remember right. But our work type, if you will see, these are all categorical variables. Okay, so we are keeping them as of now. We can change them once we are just before applying the model. Maybe we can change them to 0, 1. But now we also have a step. We have to fill in NA. Yeah, Praveen, we will be seeing how we are able to handle the NA values. If they are not a lot in number, we will try to basically fill them. If not, then we will if they are a lot of in number, we will fill them. But if not, if they are very less, then maybe we can just remove that data. Okay. So yeah, Thomas, the reason we are not doing this initially where we are changing, if you meant basically 0, 1 category, the reason is that we still have to do a lot of visualization and understanding of the data. Now, if you lose that thing, for example, let's say you change urban to 0, rural to 1, okay, let's say semi-urban or anything to 2, then when you will be creating your graphs, which we will see in the next file, okay, in the next Python notebook, you will get a graph like this basically, which will be maybe let's say you're even if you're making some complex graph 0, 1, 2, Okay, then you will have to see from key or basically add a legend here that okay, what 0 went, what 2 went. So all these things ideally are required when we are actually applying the algorithm because they are helpful to an algorithm. On that note, even before making the graphs, I will actually suggest to have these variable hypertension and heart disease also has some value. For example, heart disease should be yes, okay, and this should be hypertension like has hypertension or something, so that when we make these graphs, okay, they are better and they are self-explanatory. We will see the same, and then towards the end when we are applying the ML algorithm, we can choose to basically have them changed. Okay. Everyone just give me a quick thumbs up if everything is fine till now. Like no doubts are there. If you have any doubts, if you have any other code or any other thing which you want me to write, let me know. We can write that and see that okay what we are getting. Like we wrote the describe command and everything. So yeah, we have just done the data understanding as of now, nothing else. But yeah, this is a very important step as we have seen. Just change the types, saw what is happening and all these things. And now actually we will going towards the visualization and then we will see how it happens. Okay, I hope you are able to appreciate that. Yeah, this I would say problem is kind of going in a way the way we would be doing in industry. Okay, so if you have any feedback, any comments on that, also let me know. If all is fine, also do like the video. Okay, if you are seeing, I think yeah, you will be seeing on YouTube as of now, and do let me know on the comments if everything is fine. I do read all the comments. Okay, so please make sure that yeah, you are commenting on the same. Similarly, yeah, so we go to the new file. The file name is EDA, exploratory data analysis. According to me, one of the most important thing to do. Okay, I think this might be the biggest file. Yeah, this is the biggest file which I have made. Because as I have said, that is actually the field where I think most important things and everything gets done. Okay, so yeah, again, just some textbook libraries which we are getting. We are this time reading the read clean stroke CSV. Okay, so this is of course because I have worked on this in the back end and make sure that this is clear. Normally, if someone has worked in the field, like someone has actually worked on the project, you will basically agree with me that yeah, it should have been clean stroke 2 or 3 or something like that, because when we work on the data, we try to save up a lot of file. Okay, every time we are doing this, then there are file name issues and we have to underscore 2 or something like that. So this is a continuous project process, I'm saying. So normally what used to happen is I used to create a clean stroke, then I used to see something else and basically add on to that, then clean stroke 2, clean stroke 3. That is how basically my project normally used to happen in my job. Okay, in real life experience, that is something which will happen. Everyone makes that. I won't say that as a mistake, even that is, I think, incremental improvement. So yeah, just here everything is flowing a little smoothly because I have to explain you all, but I'm still telling these kind of, I would say, incremental improvement happen. So this was actually the first time I think I am having clean stroke and not underscore or any 2, 3 in that. Okay, so yeah, reading that data, just quickly checking that with head and everything. Just checking the shape and seeing that okay, number of unique. Okay, shape just give us that okay, how many rows are there, rows and column. Okay, then unique we are checking. So unique will actually help me to understand. For example, gender, we have 3, male, female, and I think others is the one. Age is 83. I think it was 0 to 82. So all those values are present. Okay, but I don't still think that it's a categorical variable. Okay, maybe we can bin age. So there is a process of binning as well. So let's say what I can do, I can make bins from 0 to 10, 10 to 20, 20 to 30. These kind of things can then be actually, I would say, classified as categorical. But as of now, I don't think this makes sense. Heart disease 2, heart disease, ever married, hypertension, all these are having the values. These, of course, doesn't seems to be our, I would say, categorical value. Okay, BMI and average glucose level is that. Then smoking status and stroke. Stroke is our target variable and smoking status, 4 values are there. Okay, cool. So this slide will be actually, this overall will be very good. Okay, so we are now searching for duplicates in our data set. So we see that okay, we don't have any duplicates in data set. Now let us see the df.describe. So yeah, if you will see now, just the describe thing which we ran in the last, also based on Thomas' suggestion. Yeah, so we are just give us an idea that okay, if I see age is from 0 to 82, and it seems to be like a very good divide to me. Around 45 is where everything is happening. Okay, so people less than 45, 82 is the highest. So seems like the distribution is pretty good in that way. hypertension and all is basically a overall idea. Then let's see on the average glucose level. Okay, so 75th percentile and this. Based on my knowledge, I know that like around everything around 120, 110 is basically the right glucose level. Like it is still acceptable. Okay, then minimum is 55. These glucose levels seems to be fine to me, but the max is 271. So of course, few people are there. Okay, so just the way what I'm trying to explain you all here is, so let us see. Like this is actually, let me use a different pen. So just trying to make, so see, it is not like you just have to run these commands. You also have to make sure that you are making sense of this data. Okay, this is my glucose level. This is 50th percentile, 75, 75, 25. So if I see the values, and this is what I will expect all of you to also do. So we have the minimum as 55, which just seems okay, 77. And the 50th percentile is actually, okay, sorry, my bad, 55, 77. Then 91 is something which we have in middle. 75 percentile is 114 and 271 is there. So based on what I have an idea, okay, I remember that this value is around, like I think 110, 120 is still fine, but we do see that a lot of people are having this greater than what it should be. Okay, so this is something interference, like, yeah, 20% of people around, or let's say 15% of people, I hope their glucose level will play a part in that. Same goes for BMI. Okay, BMI is there. On the same note, let us actually understand a little bit more about BMI, what exactly it is. So body mass index, if we see value derived from the mass and height of a person, let us go to Wikipedia to quickly understand a little bit on the same. And this is the reason I'm doing all this, is because I expect you all to also do the same when you are faced with any data. Okay, this is actually what will differentiate how your model works and how not. Okay, so yeah, it is basically BMI is different body mass square of the body height and is expressed in unit kg by kilometer square. Okay, so resulting from this mass, and I think there should be some other thing as well. Yeah, see, this is basically few categories which we can use and make from our BMI. Okay, for example, there is underweight, then normal range, overweight, obese. Okay, we have the BMI values as well. So this data from internet maybe we can use basically to have some other information. Okay, so we will see on the same. Now moving forward, so yeah, these are actually few of the inferences which we have made. Okay, so let us go by one. I said that median age of population is 43 years. Does seems fine. 25% of the population is age 25. So this seems actually to be like a very good, I would say, with respect to population. It is not skewed towards anything. Like if the 82 is highest and 0 is the lowest, then middle you have around 43. So around 25 was that thing. Okay. 25% is the age above 60 and remaining in between these ages. This we can, average glucose level of the population is XO 106. So this also help us on the same. Okay, 9.7% and 5.4% suffer from hypertension and heart disease. Okay, this of course is also one very important thing. People with higher BMI greater than 45 less represented. This can affect our machine learning model significantly because we don't have a lot of variance in that thing. So BMI, if we see, so the mean of BMI is 28. Okay, I think this is around the normal age. If I remember, 27 is the normal age. So yeah, we are not having a lot of, I would say, variance in this, but we will see how that helps or basically give us an issue. Cool. If anyone has any doubt till now, let me know in the comments. Okay, I will now explain you the next line of code. So we are just making a copy of our data eda._df. Reason we are not just using df here, okay, is because then it refers to the same variable. Now 10 we are changing, as I suggested, we will be changing 10 to basically the value which will be able to helpful to us. Okay, so for example, for hypertension, we are changing this to hypertension and no hypertension. Heart disease, no heart disease. Yes and no stroke. Yes, ever married and never. Okay, this is what we are changing. The reason is that we will be making a lot of graphs now. So we want that, okay, these kind of things is very visible in the graph. Okay. So if you will see now, data has basically changed to just tell us a little bit more on the same. Hypertension, instead of 0, 1, it is no hypertension, no heart disease. These things help us a lot. Okay, when we will be now making any univariate or bivariate analysis. Okay. Then I am just calculating percent of population. Let me try to explain a little bit on this. So this is just population which has 35 to 45 BMI and 45 to 60 BMI. Okay. So just basically calculating, and so what I'm doing here is I'm just, I would say, first kind of filtering less than 45, less than 45 and greater than 35. It gives us a mere true false array, and then just dividing that by the number of total entries. Okay, pretty straightforward. What I've just done is calculated that okay, how many people are having that out of total population. Okay, if everything is clear till now, we will be actually starting with univariate analysis. What univariate analysis actually mean is uni means single. Okay, variate kind of means variable. So single variable we will be actually now checking. We will take a single variable and we will check that okay, how that affects our data, what is the variance in that data, how that data is basically, I would say, overall giving you an idea. Okay, so let me know if anyone has any doubt or anything in this. Okay, first you will complete this, and of course you will go to our ML model. ML model will be the easiest to apply. So, but I actually wanted all of you to take through this journey of understanding this data. Cool. And I hope you all are appreciating the way we are moving. I know I'm moving a little slowly because I want to stress and also make sure that everyone understands this thing. Okay. So cool. Now, actually, yeah. Okay, let me try to explain a little bit on this. What is happening? We are just PLT is matplot, so we are just initiating a figure. Then figure may we are adding the axis 0011. I think if I remember right, this was x start x end. Like that. Gender we have three things: gender, female, male, others. We just are now calculating the counts. Okay, counts. Then we are creating bar, axis dot bar we are adding, and then title is basically we are adding a title, and plot show finally shows us the plot. And similarly, we are also calculating our percentages. Okay. So if we see, I have to zoom out a little bit, I think, yeah. So yeah, if we see, this is somewhere around our graph which we have got. We can see from the graph as well. Okay, so if you will see here, so we have gender distribution, 3,000 around women are there and everything. So this is actually 58% are female, 41% is male, and it is 0.00019. Okay, so hardly very less other kind of basically thing is there. So that can actually be treated as a noise, honestly, for our data set. So we should be very good to get rid of this. Okay, let me know if anyone has any problem. This is just a very simple information. So made gender interference as well, amount of female patient and male patient in the data set, almost no patient in the gender category, so we can drop it. Okay, so this we have actually made some inference now based on the univariate analysis. Quickly moving forward, we have data frame. We have created a copy. 1 second. So what I'm now doing is I'm creating some bins for the ages, because to make sure, see, thing is we have ages from 0 to 82. Now having any graph like this will be a little difficult for me to understand. Okay, if I have any graph like this for each age, okay, this will be a little bit difficult for me to understand. But the way we actually understand something that okay, what is the chance of getting a stroke after 30, what is the chance of getting a stroke when you are from 10 to 20, that we have seen that our data is also, I would say, in basically it is very normally distributed around age, right? So it is basically having all that characteristics. So we are just binning that thing. Okay, if you will see here, we have created a new variable in DT2. We have first made a copy, and then in that we have created an age group where we are using pd.cut function, and I'm cutting my ages into this bins. Okay, so this bins basically help us to basically now divide all people from 0 to let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They will all be in a range or in a bin 0 to 10. Okay, so moving forward, we have a plot here. This is more or less pretty straightforward. Let us generate this. So yeah, this is actually the data which we saw. Okay, this is like, if you will see, for a particular age, if you will see that this is, the legend is here, no stroke and stroke. You can see the code that is very easy and normally explanatory. So you will see that what is happening is this actually kind of I think as an outlier, that okay, person at age 1 is getting a stroke. Similarly around 14 as well, but this thing is getting a lot increase when we move in age. Okay, can anyone like, I hope everyone is able to understand this thing clearly, that what is actually is happening here. Okay, and these kind of actually are the graphs which you include in your report, or let's say include in your PPT or the project report which you make to present it to someone, right? This overall helps you understand the same thing too. I would say we also had an idea that with age the number of cases and strokes should increase, but we are able to now see that in real life, okay, by plotting this data. That is why this is important. Okay, so just Let me know if any issues are there. If everything is clear till now, just give me a quick yes or thumbs up so that we can move forward with the same. High race tend to have more heart stroke, right? Mohammed, yeah, that is what we are able to see. So that is for, see, there are two things always. Okay. The very first thing is, Mohammed, like this is the very general observation which we have, right? That higher age, people with higher age gets more heart stroke. That is what we normally know. Okay, like it is similar to, like, let's say we can say that person who is eating a lot of sugar, he will be overweight and everything. But we also have to make sure that what general, I would say, uh, I wouldn't like to say PG, it is like what general idea we have is the data also representative of that. It may happen that I have given you a completely different data, which is, let's say, the data title or something is that number of, let's say, heart rate cases in heart stroke cases in child, or let's say in age below 30. Okay, then it may happen that your data is basically towards this, it is happening. Okay, so whatever inferences which we have normally, we have to make sure that we are able to get that clear via data also, and our data should be representative of the same. Okay, it may happen that normally it is given that, let's say, with gray, like with age is high, then this kind of issues are there. But what if the data is actually taken from some part, okay, where that disease is completely non, I would say, present. Okay, for example, in India, subcontinent diabetes is there, a lot of issue is there, but I think that is not that predominant in Europe. Okay, so in Europe, it may happen that, yeah, people who are having diabetes, that is because of some genuine case and not because of their eating habits and as such. Okay, so we have to, Mohammed, make sure that any general idea of things which we have, we don't forcefully force on our data. That is very important. Okay, any of the inferences, your data should also let you know. Okay, you should not force them on your data. That thing is very important and will actually be very helpful when you do your projects in any company. Okay, I see a lot of people, what mistake they do is, the PGDs, or let's say the understanding which they have, okay, they try to force that on the data and get that out. That should never be the case. We had that understanding that, yeah, more age might lead to more heart stroke, but we let our data explain that to us instead of, let's say, going the other way where we are calculating, let's say, just we are taking 50 to 80 age and then calculating the same. No, we didn't do that. We saw the full, I would say, age ranges. Okay, someone might have done, let's say, just taken this data. Okay, and he would have said that, hey, I told her that after 60, the, like, let's say, the number of cases increases. Okay. Charan is saying, I'm not able to launch the ineuron lab. Anyone face this? Charan, I think ineuron lab, I would connect with the team once. I would connect with the technical team once. I think that is just available to the paid user. I'm not exactly sure. Okay, if you have actually enrolled in a course, but let me check and get back on that. Okay, meanwhile, I think it will be, I will be sharing you these files, all these files. You can run them locally on your computer. I have not kept this file very heavy or data very heavy for the same reason that I don't want that if someone, let's say, have any issues, I am pretty sure that these files or this code will somehow be able to run on the basically mobile as well. Okay, Charan. So let me check that with the technical team. Okay, maybe you can raise some support query or something, but I will check and also get back when we have that. Should we apply hypothesis testing? No, Mohammed. As of now, we don't have to apply any hypothesis testing or anything. Matlab, we are just right now doing univariate analysis on this, right? Hypothesis testing is when you take some hypothesis that, okay, this is happening, and then you use some statistical model for that. Okay. Here we are not doing all these things. We are just doing normal things. See, one more thing which I would actually like all of you to understand: data science tends to be easy. Okay, and it becomes a lot complex if you want to make it like that. Just take a problem as a generic problem would be, okay, and then try to apply things as they come. For example, hypothesis testing, which Mohammed is referring to, we are just doing some normal univariate analysis as of now. Okay, hypothesis testing is something other where we take some assumption and then we have to calculate p value, t value. Of course, those things are there. Okay, but for the data which is making sense, it is very better to, just go with the flow and understand the data as you will. Because if you will be able to understand that, that will be very helpful for you to even explain that to others and apply your model. That is where I see a lot of students making that mistake. A lot of people actually in the industry also making the mistake, where they are, I would say, a lot on the technical details, all these hard terms and all these things. Okay, and what happens is that they end up making the project or problem a lot more complex. Okay, you just learn these all these terms, but whenever you're doing project, that is very different, and that ideally should be different if you want to actually get the results. Okay, as you will see in this also. Okay, So Mohammed and Charan, I hope I was able to answer your question. Charan, I will actually check that with the team and get back. No worries. So just you can have that. We are just now seeing percentage of stroke patient in decade. So what I meant by decade is I did beginning of my age column, if you remember. So just yeah, in 0 to 10 expected data, the way it is increasing very much expected. Our data is also basically supporting this. So here instead of just seeing the number of cases, the absolute number of cases, we have calculated the percentage. So for example, if we have people, let's say 100 people from 70 to 80, then it kind of means that 20% of them had a heart stroke. Okay. So this is what we have done. I hope you will be able to appreciate that this kind of analysis. Okay, ideally we should not have just stopped here, because if someone will see here, he will say that hey, this seems to be decreasing, this seems to be decreasing, then decreasing, but it is not the case. You have to also see the how long the bars are going. Okay, so that thing is also very important. This kind of just shows that okay, this is helpful in understanding that yeah, the number of stroke cases increase as we are in age. These kind of seems like some outliers, but we will see how to handle that. Okay. Then some inferences, age distribution shows that age data is slightly skewed left, as we can see. So as I said, this seems to be some outliers. We have to going like this. Okay. With respect to the target variable overall, and greater number of patients from older age groups. That of course is also understandable. Now we are actually, so if you remember, we saw the BMI thing. So we are just dividing BMI into these categories. Okay, underweight, overweight. Now we will actually see that okay, how BMI has an effect on if a person will be having a stroke or not. Okay. Uh, let me first make the BMI. Okay, so just let me try to explain this. We are just using PLT subplots. Again, you can do same thing. I don't want you to get dependent on anyone. That is my suggestion. Just search BN like matplotlib subplots, and you can see that okay, all the I would say idea about that, what that particular library is, how we can make that. There are some parameters which you have to pass, n rows, n column, then all these things, learn about them, and we will be doing that. So now we are just creating a subplot class. Then we have just divided our data. So if BMI is less than 18.5, okay, count that value. Less than 25, greater than 18, then count that value. Okay, and we are adding labels. So we are dividing BMI in this range 18.5, 25, 30, and greater than 30. Adding labels: underweight, normal weight, overweight, and this. Okay, then these are some colors and everything which you have suggested in the PCT values and radius. Then axis should be equal. Okay, and then legend. So we will let me quickly see that okay, what this will give. Just a second. Yeah, cool. So it is also giving us an idea now. Let us see what we can make of this thing. Okay. If we see underweight people are having less strokes. Okay, somehow that is an interference which you can get from inference. Sorry, for which you can get from the data. Normal people and overweight people seems to having the BA like the number of cases around equal. Okay, but that said, once someone is obese, the overall I would say chances of stroke increase a lot. Okay, so if as all of us are aware, right, that what happens, let's say these studies come out, right, that okay, this is having an effect, this thing is having an effect. So these kind of analysis is only done. Okay, so yeah, quickly moving forward. Let us draw another graph. So this is BMI of all patient sample with stroke and without stroke. Okay, so just this is a little bit I would say graph which kind of is a little bit complex, but let us try to just understand the graph directly. Okay, here we have made this and just divided BMI of all the patient. So axis we have actually divided in this way and just colored them, lavender, tan, and everything. So this is what we have done and added those labels. Okay, so if you will see here, these are the BMI of patient and these are basically the range overall. So we can see that yeah, obese people are having a lot of chance of having that thing. Okay, similarly this goes. So this we have with respect to the BMI of the patient and what is the count. Okay, cool. So just quickly moving forward, I will make some quick graphs as well again. So here what we have done is we have the subplot, then we are making a pie. Okay, pie chart we are making. Then BMI and stroke actually we are now seeing. So what we are now seeing is that from the person who got the stroke. Okay, what is actually, I think I did that thing. This data I actually interpreted differently. This is just the, I would say, how the data is there in my data. So what is basically the BMI when I divide them into overweight, obese, and underweight. Okay, but this is when this data is actually, I would say, connected with stroke. Okay, so overweight people are having a lot, of obese are having a lot. So normal weight is this and 0.5. So this is percentage of stroke for each BMI category. So this is exactly like, let's say if I have 100 people, then 17.7 people will get stroke in that if they are from normal BMI category. Okay, so this just makes the underweight is actually the safest in that way. Okay, so let me quickly move forward. Strokes depend on BMI. We can see that most of the strokes are those who are overweight and their BMI is more than 25. Okay, so anyone has any doubt or anything till now, please just give me a quick yes, thumbs up if like everything is clear. Okay, or you may want me to explain this thing. I know this is not something which we have studied, but this is very intuitive, I hope. Okay, what we are doing here, we are just seeing each variable and we are just actually moving forward. Okay, meanwhile, let me quickly now graph, like see other graphs. So this is the hypertension distribution, very simple plot. Just give me a quick yes, thumbs up, or let me know if any doubts are there. Okay, quick yes, thumbs up will be helpful to know that yeah, people are actually understanding things. Then there is basically hypertension. We can see that yeah, hypertension no is basically a lot of people are having no as hypertension. Okay, then hypertension. So we can see that amount of major hypertension is significantly less, as we can see, right? This is the number of around 500, 600 would be the number. Similarly, we can do the same for heart disease. Cool, thanks, Thomas. So yeah, heart disease similarly, more patient without heart disease. Okay, so all this is univariate analysis which we are quickly doing. Underweight is very rare. So what we should do? No, Mohammed, what is happening is that underweight kind of people, like the people who are getting stroke in that underweight categories is less. Okay, and underweight overall in that way is less, but we do have basically a good number of underweight people. I think it was around 16-17%. Also, around from that 16-17%, I think very less people were getting that thing, getting the stroke. Okay, so we will see how to handle it, but it is not that the data points are less. It is just that the number of people who are getting stroke in that is less. Maybe we can drop those values. Maybe we will see, but yeah, we will handle that. Okay. Then we are similarly seeing for marriage and marriage status interference. So yeah, sorry, this was actually on the marriage status. Okay, so we can see that people who have never been married 1757, so around like it is around 33 to 6, like 1:3 kind of a distribution around. Okay, their marriage status who have never been married. Okay, so this just shows that okay, this data is having a lot of people who have never been married, more than half of the amount who have been married. Okay, similarly, just we will quickly. So this is just simple, I would say, bar graph which we make. Okay, this is very easy in Excel only. So private, the people who are in private, this is very high. Okay, similarly, self-employed, government jobs, these are the values. So of course, it will be having something where the private people are having, let's say, stroke. It may, one can interfere in that. Okay, stroke, if the people is getting a stroke, he is having a private job, but that is not always the case. Like the data is very high. That is which I mentioned and basically want you to understand. Okay, quickly we can move forward. Amount of patient is private work type, and least amount is never worked. Maybe we can get rid of that also. Then we have this urban and rural. This seems to be pretty straightforward only. Equal amount is there. Then let us see the smoking status quickly. So if we see formerly smoked, never smoked, smokes and unknown. Okay, these are the few values which we have for smoking. So just some kind of analysis which we are doing now. Smoking status of all the patient was smoking status is known. The greatest amount is never smoking. Okay, maybe people have lied on their particular thing. Maybe we have to calculate for the unknown. Maybe we will have to see on the basis of BMI and everything. But right now we can just see that okay, it is unknown. Then yeah, few things on numerical column quickly. This is the glucose. So what I have done here is just this plot. I have actually made this plot is basically this thing is there, and we have the AXV line. The line is actually on the median. Okay, so median and mean, then we are calculating. Median is this, mean is this. This is kind of our graph, okay, for the glucose level, and this is coming out to be as a median. Okay, so kind of skewed towards the right side as I can see here. Okay, Then glucose level is the average glucose level is skewed right, as I said, with a major peak around 80 and smaller peak around those, so 210. So we can see the same, right? Around 80 is where I'm getting this peak, and around 210 is where I'm getting the other peak. Okay. Cool. Let me click clear and move forward. Glucose level inference. Let us quickly do that. Now BMI distribution similarly. So these were the numerical variables. That's why we are working on them like this. This we can see is very rightly skewed where no even that thing is there. So this has some, I would say the BMI has some outliers, okay, which is causing us this issue. Okay, skewed right. Majority of patient have BMI 20 to 40, median is 28.4. Okay. So everyone, till now we have actually done our analysis on all of the single variable. Just give me a quick yes, thumbs up if everything is clear or if any doubts are there, because now we will move towards bivariate analysis. Okay, this thing is very important to understand the problem. We will apply a lot of ML algorithm as well. I think I have applied 5 algorithms to see okay what exactly is happening. But I hope till now everything is clear. Just give me a quick yes, thumbs up. This actually is a very good project which I would say beginners can show and actually understand on the make. I would say in an interview explain that okay you got this kind of a data from let's say some hospital or something, and that is how you worked on that. Can I get a quick thumbs up or yes if everything is clear till now? Because we will be starting with bivariate analysis. So as the name suggests, bi is now we will be taking two variables and see that okay what is happening. Okay. So the first which we are taking is with respect to smoke with respect to gender, to see that okay how many people are smoking with respect to a particular gender. So we can see male, female, other. Actually we can just ignore. That is some inferences which we have made, but because the female data was more, we can see that like female who smokes is also a little less. Yes, Thomas, everything will be shared. All the notebooks, all this data. So everything will be shared with you. You can play around with all the graphs. You can actually add your own inferences. You can make sure to add other algorithms. So all of the things which I'm using here will make sure to basically share that with you. You can enroll in the ineuron and download that from the resources. So everything will be available. If not, you can reach out to me personally on LinkedIn or anywhere, and I will make sure that you get all these files. Okay, because I want all of you to guys to have a mini project from this course which you can show and which you can learn upon. Main thing is which you should be able to learn upon. And once you will also learn all these things on your own, like run all these things on your own, you will be able to appreciate that okay yeah what all is happening here. Okay. Then yeah, a small portion of both males and females data set experience stroke. It seems that amount of those who experience stroke in both genders are about the same. So that thing is there. Okay. So we can see that yeah, more or less this is the same basically distribution. Then let us work on other inferences. Then smoke distribution by hypertension. Okay, so this is actually not that kind of a data where let's say a lot of people are smoking. Okay, so if someone would have a data where let's say they have specifically reached out to smoker group, okay, then this will be a very data where a lot of people would be smoking, and then we will be working on that. So again, not I would say fixing. We have not applied any filter and let data speak to us. Many people what they will do is they will apply this filter that okay she should smoke because it is their understanding that smoking causes this stroke. Okay. Public platform to practice any AI ML and don't have a GPU. Blue Thunder Vampire, you can actually use Google Colab is there. Okay, I think that is very straightforward and honestly, I think that should be able to do most of the work. I think there is something from Code Spaces, if I remember it, that thing was also there. Okay, which you can use because honestly, if I tell most of the ML, and everything which I have learned, actually that is also on a very basic laptop. Like I do remember the fans were actually like making a lot of noise, and I used to like just leave that on training for 6, 7, 8 hours many times. Okay, especially in CNN and heavy data models. But maybe for the timing, you can use Google Colab. Okay, Kaggle actually Thomas is a platform where you can practice problem. He is asking for a public platform to practice as he don't have a GPU. I think he mentioned Blue Thunder basically mean that he wants to write code somewhere, right? Kaggle, I think yeah. If although yeah, I think Kaggle also gives that thing. It has been some time. Like I have actually been focusing more on practical problems and stuff. Okay, not on competition since a lot of time. But if I remember, Kaggle also started giving some GPU power to you to basically run that. And I think it was actually under Google Colab only. If I remember it, Kaggle was actually bought. Maybe I might be wrong, but yeah, by Google. But yeah, like Google Colab and these things you can run on. Otherwise, I will suggest even if you don't have a GPU, take part of data and work on that. It should not be I would say it should not stop you from learning at least. That is what I am suggesting. Take some data and work on that instead. Okay, just take some part of data, like say don't work on lakh rows, work on other rows. Okay, yeah. So cool. Thanks, Thomas, for the clarification. Yeah. So it is providing. Now we are just seeing that okay, stroke. So as we said that it was a bivariate analysis. So stroke versus hypertension. 1 second. Everything is clear. So yeah, we can see that yeah, no hypertension. Okay, so this is actually kind of I would say the people who are having no hypertension. This is the number of people, and this is with hypertension. Okay, so patients that did not suffer from hypertension had larger number of stroke cases. Kind of I would say this is basically different than what we might have expected. But no hypertension people are also getting more number of cases, but of course the percentage is pretty less. Okay, so that is something. Then moving forward, let us see the heart disease with respect to slope. Similarly, no heart disease, people are more, so that's why the entries are also more. Okay, we have to make that, okay, to show that. But this also proves the point that it is not that if heart disease is not there, you won't get a stroke. Okay, so this kind of thing is also required. Then inferences is the same only here. Then let us make with the married thing. That would be great to see. Same thing. If they have ever been married, more number of cases than that. Okay, so kind of seen that yeah, greater amount of patients that were married experienced stroke than those who were not married. No inferences as such. And the thing is also that we have a lot of cases on ever married as well. But yeah, it just shows that yeah, if people are ever married, then we are getting that a lot in our data. Then stroke by work type. So as you can see, private, all the data was having a lot. So the same kind of thing is there. Okay, so just running that quickly. Inferences is basically the same. Most people who work at a private company had a stroke, experienced stroke, worked in private jobs. So this thing is there. Let me make this graph. So residence time, actually this we will see similar only. Okay, so I actually expected that rural people will have less cases of stroke. We have same number of urban and rural people. Where the data get mobile, I would be sharing all the data and this files with you. I think they would be uploaded on ineuron resources. Will tell you from where you can access them. Okay, actually let me tell that only. I don't think they are uploaded as of now. They will be done after I complete the class. So you can go here. Then you can go on Mayank Agarwal. You can just go enroll now. You must be already enrolled. So any class which I take, okay, the resources are here. So once we complete this class, decision metric is the last class which we have here. So once we complete this class, you will have the class as well as the resources part. So you will get all the data and everything there. You can actually work. I will also be providing all the code files which I'm using. Okay, cool. So let us now make with stroke and smoking status. Residence thing, as I said, this is a little bit contradictory to what I assume. I assume that rural people will be having less kind of stroke. Okay, but that is not the case. We have equal number around rural and urban, and we can see the stroke is also almost the same. Okay, then by smoking status, okay, here it let us understand on the data. So no, if we see on stroke, never smoke people are getting that. Basically, they are getting strokes even. Okay, and similarly for smoking, this is the thing. But yeah, we know that data for never smoker is also pretty high. Okay. So then multivariate analysis is basically now smoking state has little influence on probability of having a stroke. That is, yeah, of course, very contradictory, but yeah, that is what we have from our data. Okay, not fixing or making anything on that note. Then multivariate analysis, let us just plot some pair plots. Those are just for the data. Just it will take a little time. Yeah, so pair plot, what we are doing here is we are basically plotting this thing. So what pair plot does is it will take multiple variables and just help us to understand that. We are doing this on age, average glucose level and BMI. These were all our continuous variable. Okay. So we can see that, yeah, these are the graphs which we have got. Okay. And the inferences on the basis of the pair that there is positive association between BMI and BMI and average glucose level. Okay, so how we understand that is age is there, then similarly BMI is here. Okay, so if you will see, this is kind of a line which we are getting, and as the age is increasing, BMI basically is kind of also increasing. Okay, so this is how you basically learn. I would say, uh, just understand on this graph. Okay. Now correlation analysis we can also quickly do. Correlation, I hope all of you should know by now. Correlation is just that, okay, what effect is one of the value having on the other variable. It is giving us some error. Strange, I ran this yesterday, but let us see. Convert string to float. Okay, let me see this. What we are doing. So we have a heat map, and strange, 1 second, let me see if I have messed up some value. Just give me a second. Good that we faced an issue. We will even see that, okay, what is happening. So it is saying that could not convert string to float. Okay, what maybe we can do is df, I think it was gender, is equals to df. Let me actually correct this thing quickly. Function. Meanwhile, if anyone has any doubt, please ask them in the comment. Okay, so we can actually just do quickly string to float, Python, pandas, and gender. We should be able to get this thing. And what we can actually just use is the map function. Should be pretty straightforward, available to us, which we can use. So something like this does helps. Yeah, so this is actually what we can directly use. We actually, yeah, Thomas, that is why I'm getting this error, but no worries, it should be fine. df base is of course not defined. Actually, what I should do here is df underscore base is equals to df dot copy, and we can use df underscore base only. Now it should be given this for, okay, I don't have a gender key. Let us see what was the gender. Okay, small. So of course you will also face a lot of error whenever you do any language. That should be acceptable. Could not convert float to string. Yes, okay, I think I have done this conversion afterwards. We'll see that. Meanwhile, let us see some other things. Okay, I will correct that. In interest of time, let us move forward. Some issue with respect to categorical variable is which we are facing. Okay, so we can actually correct that. I think last year which we got was regard to yes. So yes is something which we are having in the, okay, we're married, I think is facing that yes issue. So should be fine. We should be able to correct that. That I will see and correct and then share the file. So meanwhile, yeah, with just to time, let us see some other graphs. Okay, so here we are taking age, average glucose level, and BMI. These are basically all our again all our continuous variables. Okay, so we are making this that age of course are highly correlated, and we saw the same I think earlier that yeah, this is basically also becoming a little bit like this. Glucose level is something like this only with respect to BMI. Okay, so this is like age. Okay, then BMI, and this is age and BMI. Yeah, so we're just seeing that, okay, what is the correlation between them. So we can see that higher body mass index you get the higher average glucose level, and then we can see that the older you get the higher your body mass index will be. Okay, this is something which we are able to see, right? So the way we have to actually see this data is that for average glucose level with age, this is how it is happening. And average glucose level with BMI, the older we are getting, BMI is increasing. Similarly, with because these are the variables which one have to see. Okay, BMI. So a question, generally in healthcare we have highly imbalanced data, so it is right to apply SMOT or SMOT, okay, to add synthetic data. Yeah, Ram, that does happens. Okay, we will actually see. I think in this also we have. So other people who are not aware of this, let me tell you what Ram is basically suggesting. So in any healthcare data, okay, what happened is that we have the data is very much skewed or very much imbalanced. Where, for example, if you have 10 lakh cases, then around 200 or let's say 500 or let's say around 700, 800 people will be having a stroke and all other will not be having. Okay, in that way, what we have to do is we can either basically first let us try to understand what exactly we can do. Either we can remove the other class, the I would say heavy class, okay, no stroke class, we can remove some variables, or we can increase basically the class which we are having. So for that, Ram is suggesting that basically smooth toolkit is used to add synthetic data. So let's say if I have 800 cases, okay, I would then just create some data, okay, using these techniques, okay, and that technique will basically then help me to increase the proportion of the data in my data set. Okay, so that is what was there. Then let us move forward. We were creating this in a one more graph. These are the box plot. I'm pretty sure that people would be aware of this. Box plot is also a very good, nicely used to understand on the, I would say, outliers. Okay, so if you will see here, stroke, this is the age with respect to stroke. Okay, and we have, I think this is, yeah, stroke. When stroke is there, few outliers are there. And I also told, right, that imbalance after PCA. After imbalance after PCA, Mohammed, I didn't understood your question. PCA is basically make if we have a lot of let's say data is there, like a lot of dimensions are there, then is PCA used. What do you understand by handling imbalance? Imbalance thing. You can actually understood it. I think it is related to Ram question only. So Mohammed, yeah, you can actually, if I remember right, is it good to handle imbalance after PCA? I particularly suggest to just work on the data first and basically handle that imbalance first. Okay, first get all these insights. Okay, and then is when we will be basically applying this mode and other analysis. The thing is that I think it is better if you understand the data. PCA will give you the variables or new dimensions which you might not be able to make much sense of. Okay, you can apply mode analysis after that, but I don't think that then we will be able to make sense of those things. For example, here, if you apply PCA, we might get a lot of other things, other data like other dimensions, and then if we try to basically generate those data, those might not be making a little bit sense to us. So better to apply them before only. Okay. So yeah, if you remember, we had a case where stroke was for 0 age person and as well as this, but we saw that okay, it is increasing as we go forward. Okay. So now, yeah, this is actually based on BMI. BMI, we see that, yeah, for not stroke, a lot of values are there. These are the outliers, so we will have to handle that. So most patients who ever had a stroke are over the 80. Younger people can also experience it, as some outliers are there. Age of the patient is a correlation whether he will have a stroke or not. This also we saw. Okay. So quickly, everything is now clear here. Okay. Let us move to the pre-processing. So pre-processing, so see, what we have actually done till now is we have actually now worked on all of our data variables. Okay, we understood that okay, what particular data is showing, how that relate to different variables, what is the correlation, how basically for each stroke and no stroke that data is changing, all these things which we have seen. Okay. Now we will be preparing our data such that we can apply ML models onto that. So if you remember, these were all the steps which were even discussed in our first class when we have to apply data, like what all steps are there which you have to cover in supervised learning. Okay. Let me just quickly read. Class parameter in algos can be used, but which is better? 1 second. Class fit parameter in algos can be used, but which one is better? Thomas, yeah. So class fit, of course, can be used. Few algorithms suggest, basically like KNN and I think random decision tree also had a class fit algorithm. It depends a lot on the problem. Normally in healthcare sector, it is seen that it is better to use smart analysis to basically make the data, make more data. Okay, but that depends a lot on problem which you have in hand, and I would suggest to apply both of them. But normally when the data is very much skewed, okay, applying class balance. So let's say it is 99% is to 1, which happens in fraud data sets and everything. This mode analysis is basically something which can help us better. Okay. So now let us quickly start with the pre-processing file. So all these imports are there. We are using our clean stroke file. Just let us quickly see the thing. We have this variables and everything. Just let me collapse all output so that it is clear. Then let us see the so yeah, this is actually the age. Okay, box plot for the age, then hypertension, heart disease. So one second, what we are doing is we have actually made a box plot here. Okay, so age is a numerical variable, so we are having that. It has basically treat hypertension. We have not actually changed it to no hypertension and let's say yes in that. So it has also created a box plot. Zeros are these values, and one is basically you can see just here. So that's why this kind of a graph. This actually is not an issue. The issue is here. Average glucose level. We see that a lot of outliers are here, and similarly in BMI we are having a lot of outliers. Okay, so just we did this, and then stroke and everything is there. Then outlier list. We are actually just getting the outlier list. This is actually one function which we have written for detect outliers. So what is happening is we are making a copy here. Then all these values, mean value, standard deviation, all these values, then we are finding the shape, and then we are finding the boundary. So we are finding the upper bound and lower bound. It is normally 75th percentile, 25th percentile, and basically we are just checking that okay, what is the highest and lowest allowed. Okay, quickly go through function. I have written this in a very, I would say, easy to get way. So we are now detecting the outliers on average this. Okay, so if you will see here, mean value, standard deviation, minimum value, max value, highest allowed and lowest allowed. Okay, so now quickly just move, let us quickly just move forward. So this is we are making a subplot. Okay, just moving a little fast here because I want to complete this. Like we have the model training class as well. So we saw that average glucose, this glucose level with density and everything. So how the graph is getting made. Okay, similarly, what are the different outliers present here? We have just done both of this thing in the glucose level here. Okay, so these graphs we have. Then the next thing come of handling the missing values. So in the BMI, what we are doing is we are filling in the missing values with median. Okay, that is in place. So this is actually the code for what we are doing is we had some NAs. What we are doing is we calculated all the values which we have. We calculated their median. You can also use the mean. Okay, and there is also KNN, K nearest neighbor, which is used. Not taught that, but I hope you are aware. A very easy algorithm where we see that okay, where are values handling and what are its variable. So based on regression or classification problem, we take that thing. So now similarly, if we see, we have basically created a DF1, we have taken a BMI, then we have filled its NA, then all the other things which we have done. So should be straightforward to get. We'll share the code, so I think should be easy. So yeah, this is the kind of a graph which we got after filling in the NAs. Now you can see that it is very, very rightly skewed. Like a few outliers are there after this value. Okay, ideally we should be happy to get rid of those values, I believe. Okay. So this is the sync shape after removing the BMI outliers, and we have actually dropped all the BMIs. Okay, where it was greater than 47. Okay, now let us plot this quickly. I think we have made some error here, so we should actually have seen DF1 instead. I made this error. Okay, I've actually sorry, my bad. I think I have to just make DF1 again, and then it will basically make sense. We made DF1 here. So I will tell what issue, what mistake we made. So see, yeah, what is happening is initially we had this shape. We have now dropped all the outliers now. Okay, so after dropping the outliers, we have 4993. So we have actually removed around 7 and I think it's 7 and 10, around 17 outliers we have removed. Okay, so now let me just quickly see the distribution. Ideally, we should have a very good distribution now. So yeah, the I would say distribution which all data scientists want to see. It is a normal kind of a distribution. Okay, we have removed these outliers. This is actually the distribution which we are getting after removing these outliers. Then we have just some plots. Quickly, we will plot it. So what we are doing in this is we are making this plot. Okay, subplot this plot. We have this variable which we will be adding here, and we will be sending the data. Then title is before T and after T. So what we are doing is DF1 average glucose, and we are taking the log of this value to calculate that okay, what is the values and everything here. Similarly for average glucose level, all the basically things. So here actually I've done a lot of this thing. It can actually be just move forward. Just give me a minute. So yeah, these things actually I kept so that you can study on this. So data power transformer and everything. So study on this thing. Just the thing is that yeah, we have now got our data. Okay, so the data, final data we have saved in transform.csv. Okay. So now we will actually be applying model training. Okay. Anyone has any doubt in this? You can actually a lot of people won't be able to understand what I have done in this. Okay, you can actually remove. I would say as of now, just ignore this. Okay, this is something which we see on the log value, like okay, exactly what is happening with that. Okay, average glucose value, how it is changing, and all these things, and something of basically transforming the data. So applying those power transformer, those should not be causing any issue to apply our model. So now basically we're in the model training part. Okay, I think till this you can see that okay, why we apply like remove the outliers here. Okay, overall here is when we remove these outliers. Let me just clear this, and we got this data, but we were not able to remove the outliers in our, I would say, glucose level, because we have a lot of these data sets here. Okay, so everything is clear. Let us move to model training. Okay, can I get a quick yes or thumbs up if everything is clear? Here I am now importing a lot of models, as you can see, sklearn, like label encoder, pipeline, then random forest, data boost, logistic. We have run KNN. We have not studied, but yeah, decision tree, SVC, all these algorithms I'm getting. So can I get a quick yes or thumbs up? I will be sharing these files, so should be clear, and you can basically go through them. And I'm reading the transform data meanwhile. Okay. Cool. Thanks, Mohammed. Anyone has, if they have any doubt or anything, please let me know in the comments before we start our last process, which is the model training. This is actually exactly how you should even take up a problem when you get that in an industry, or let's say in any hackathon or in any problem. Okay, you should make sure that you're dividing your files on the basis of what you're doing in each file. So first one was a very generic file. Okay, so let me explain this a little bit. Thanks, Thomas. So what I see most people doing is they kind of try to make this error also, like they will make a single file and then they will basically do all of things in that file only. Okay, they will run some file here, run some command, then let's say they will come down, run some command, but then they will see that okay, they must have done that. So in the single file, basically they run commands, but they are not sequential, and then that causes the issue. What instead we should do is we should divide each of our file into different thing. Okay, so let's say we have 4 files now, like the way I'm done in this project. Okay, this file should be just for your overall, like I would say, taking the bird eye view data understanding. Okay, here we just work on our data frame. This is for data understanding. This should ideally be your file where a lot of graphs and everything you are doing. There is data, like sorry, EDA. This is your EDA, exploratory data analysis. Next is where you now prepare your data for the models. Okay, you transform the data, you add these things, you remove outliers and everything. Basically, in this file, you won't change anything in the data. Okay, it's just that you won't remove any rows. You will just see that okay, what all is happening. Do we have an outliers? Do we have NAs? All that you won't still do anything. Here is where you make that change and make sure that data is getting transformed. So the input of these both files are same only, honestly. And once so based on the even the insights from these files, okay, your EDA file, you will be preparing your data, and then finally you will be doing the model training. Once you do that in any real project and anything, basically you will see that this file is very straightforward and easy because you have done most of your heavy lifting in the previous files. Okay, once you have to just apply your model, that part becomes very easy. Okay, so I hope this thing is clear. Just let me know if you want me to explain that a little bit more. Now here I have just basically got our different kind of values, sorry, different libraries. So just basically sklearn, we are getting label encoder, pipeline, then different algorithms are here. So these kind of stuff I have just imported here. Just give me a second. I think it will take it only. Yeah. So random forest, data boost, logistic regression, all these is what we have got. Now we are just taking the data transform data. Here we have done the test change split. This random state 34, we are taking random state at 34. You can take any variable. It's just that we take this so that the way we are randomly dividing the data. Okay, just let me also explain this a little bit. So let's say we have this data set with us. Okay, now I will be dividing the rows and taking some into test, X test, and some into trained. Okay, so this happens randomly. So what random can then basically have an effect is that you train your model. Okay, it may happen that one time your model is trained, all the things are fine. Other time, basically, let's say you are getting different data. So to avoid that randomness is where we use this random state and we pass this value So using the random state, we are basically able to then, I would say, using this random state, we are able to get the same like values, same rows overall in our data set. Okay, so that's why it is passed. I actually faced a lot of issue like when I first saw that this in a code, like okay, what is RS overall? So yeah, just doing a split. So this is now we are doing, okay, let me show you this thing a little bit clearly what we are doing here. So if we see data dot head, Thomas is asking is stratified sampling is best. Stratified sampling can be used, Thomas. That is not an issue. So that is the stuff in basically what happens in each of your data side problem is that a lot of things depends on the data side. Okay, normally random sampling work very like works pretty well only. Okay, like when we take it, so that is also depending on exactly what data we have. Okay, but normally in our algorithms, let's say if it is normal, not much skewed and everything, then overall your random samplings work as good. Okay, you can of course use stratified sampling as well, where your data is actually divided into different statas and then you are dividing it. Okay, to make sure that you don't get disproportionate data sets and everything. But yeah, random. Maybe what I normally do is like what my case is that we will apply random sampling first. We will see all the data and everything, and then I will just go back and basically have different kinds of sample, like stratified sampling and other things. Then, so it is more on let us do and test. Apart from let's say, just we are making that mind that okay we will do because that's how normally in industry and normally like what happens, right? If let's say you are going with a solution to someone, he might ask that okay, have you done what was the like let's say application which you were getting by random split, then what did you try certified sampling? So all those things you will have to then show. So it's better you start with random first, even if you are getting wrong results, follow that process and then move to stratified. Mohammed is asking if we will handle missing values or outliers in after EDA, right? So we have actually handled that in the last slide, Mohammed. This we are just handling. This we are just applying the models. Okay. So yeah, this now I'm basically doing the encoding of my variables. Okay, so whatever variables are of, let me do one thing. Extrain dot head. So you will see that earlier I was having private self-employed. So I will just explain this a little bit also. So what happened is that for us this makes sense that a person is let's say in let's say residence type. Okay. For us it makes a lot of sense that a person is basically let's say urban or rural. Okay, we can work a lot on this with this information and everything, but for model this is as good as something is 0 and something as 1. Basically they are different categories. Okay, it is very important to understand that the more numerical or let's say the more less easy data we give our model to understand, our model just understand that hey, 1 is some type of work or living arrangement and 0 is some other kind of living arrangement. Okay, it will still work if you provide bang like let's say urban and rural. Okay, but still it is fine. It is better if you provide your data by encoding. That's why we basically just said that. One second, let me go back. Yeah, so that's why actually we have removed all these private, self-employed, rural, urban, yes, no to this thing, basically 0, 1. So our model is basically able to quickly work on the same. Okay. So that's why we have just applied these encoders. So now actually the issue which a lot of people were talking about that is coming. We are seeing that okay, we do have an imbalanced kind of a data set, 4, 7, 4, 7 and 6. Okay. So I think someone had a question on this also, that what kind of data we are having. One second. Yeah. So we are having an imbalanced data here also because this is a healthcare problem. So people who are getting stroke, second, people who don't know, who are not getting stroke is basically 4,700, while just 250, around 250 people are there who are getting the stroke. Okay. So there are two ways, as I said, to handle this thing: undersampling, removing records of majority class. That is, we will make this less. This is the very first intuition or understanding what we will do. The second is oversampling, copying records of binary class. So smooth and other analysis are used here. Okay. 1 second. Yeah. So now what you are doing is basically this is just one function which I have written to calculate some metrics. Okay. So I've also removed few of the values here. Just once we understand that or once you read about them, then uncomment it or see them also. I don't want to make it complicated. We have just seen classification metrics and accuracy based only. Okay, so very first is we are applying logistic regression. This is a logistic regression line and we are basically getting an accuracy of 95. Okay, as you can see, let me just zoom in a little bit. We are getting an accuracy of 95. Okay, seems a very good accuracy, but it's not. It is just classifying everything as in the first class. Okay, as you can see, this is 0. So I think we discussed this in the classification metric as well. Okay, here what we are saying to people are like everyone we are saying that you don't get a stroke. So if let's say if someone is obese, someone is let's say having high hypertension, heart disease, we are just saying that yeah, you will have a stroke. So that's why this model, though accuracy is 95, but is not representative of all. AOC, okay, AOC is something which I have removed, but yeah, the model prediction is very random. Okay. Then we are just making a copy and splitting our classes. So here we are doing undersampling. Okay, what I mean by undersampling is we are removing some values in the major class. Okay, just let me keep it here. So we are just doing some undersampling. Okay, so train downsample if you will see here. Okay, we have just resampled it and then concatenated it to our data set. So yeah, now both of them is having basically 189 and 189 values. Now I'm training on my downsample data. Okay, here you see now, if you will see, I have trained on my downsample data and now I'm predicting on the X test only. Okay, so if you will see here, what is happening is pretty much straightforward. Downsampled Y, downsampled X. This is my model. Okay, and then we are fitting on this downsample data, but we are predicting for X test only. Okay, and then we are passing on that classification info function Y test and Y predicted. But sorry for that. Yeah, we will see that still our model has some increased, I would say, cases where it is now able to even predict something better. Okay, so confusion matrix is there. We have an accuracy which is a little bit low, but we know that at least it is not random. Okay, that thing is very important to understand. This 73% accuracy is better than my 95% accuracy, because at least if people are around, I think it was around how many there, 46 plus 11, around 57. So around 57 we are able to tell that okay, 46 people that you might have a chance of stroke. Okay, this 11 unclassified still feel fine and this value is still fine. If we are saying that hey, you will get a stroke, but you will not, the person in the worst case will just get a test done. Okay, cool. Moving forward, next is oversampling. Okay, so what we are doing is we are just basically upsampling now. So we will just make some copies of that. That is just more analysis. Others are also useful. Okay, so similarly we are just applying logistic regression here. We are seeing almost the similar accuracy and everything. So accuracy is around 74%, training accuracy is around this. So 45 now we are telling, and this thing. Let us use decision tree now. I'm not going through the individual line here. It is just decision tree classifier is there. We are using the pipeline, and then fitting we are doing, and then basically accuracy score we are predicting. Okay, so very simple, straightforward line code basis. That's why I always say that this is normally it is very easy to apply ML algorithms. Okay, we might just have to play with some hyperparameters, some tuning and other things. You should know about the model, that is for sure. But application of model that happens in a very focus will be on recall value. Yes, Thomas. So okay, I think I have not specifically shared on the recall and bias, variance, recall, and precision. Okay. So, but yeah, in this problem, we will be majorly focusing on, I would say, let us keep it like that, that we will be focusing on the people who are going to get a stroke, but we predict them that they are not going to have a stroke. Okay. So in our data, this thing is there. So we are predicting that out of 57, 50 people will not be getting a stroke. Okay. Now that is a very bad thing to do. So overall the accuracy is increased, but still this is not a good thing. And we can also see that it is overfitting. Training accuracy is 1. Okay. So it is a very high bias, low variance kind of a thing which is happening. Read about those terms. I intend to cover that in my data science community class, which I will take. Okay. Similarly, random forest. So we saw that here linear regression, logistic regression was doing pretty much good only. Similarly, random forest also kind of behaves pretty badly, as we can see. Accuracy is pretty fine. It is also kind of doing this. So random forest, I think we have not studied on the same. So let me just take a quick minute to explain about boosting algorithms. So what happens in boosting algorithm is that, let's say we create multiple these algorithms. So let's say in random forest all these are decision tree. Okay, we will actually, what we will be doing is we will be passing some data, some rows and columns, basically, which are features to each of these decision tree. They will basically be random, and in each of that we will be doing some bagging. So we will be passing the error also, and based on what each of them are saying. Okay, so let's say it said yes, it said no. Yes, we will be preparing 100 of those trees and we will take the majority thing. So finally we can say that okay, this is yes. So this is a little bit idea about decision tree that we make a random forest. So as the name suggests, forest. Okay, we will have multiple decision trees. Based on what each decision trees is basically giving us the output, we will take that. Okay. Yeah, that is the bagging concept. I actually intend to cover that pretty nicely. Only don't want to just run through concept, but yeah, just have applied them to show you that okay, it is applying the any model or anything is pretty easy. So that should be doable. And similarly, ADA boost is there. So ADA boost also we basically have a lot of these algorithms. Okay, each of one is basically, let's say, doing some mistake. Each of them is a weak learner, but when we basically just, I would say, aggregate the learnings, aggregate all of the model performance, all of the model understanding, then is when we basically get that thing. Okay. So here also we see that we are getting a good accuracy. It is overfitting, but like overall this is also not doing well. So I think with undersampling and applying the logistic regression is when we are getting the best model. Pickle file is basically just used to basically save your models. Okay, I think you can, for anyone who is starting in the ML, they can just avoid this for now. So model, whatever the model has learned, it is basically used to just just store that value, store whatever the model has learned. So tomorrow, if you want to, let's say, share those learnings with someone, you can just send that file. You won't be sending all these things and basically then expect that he will be training from scratch and everything, right? So that is where this pickle file is used. So yeah, this actually kind of completes our case study. Okay, we have actually, what all we have done here in this case study is, of course, that we saw that yeah, we have. Let me go to this slide only. So here all. Let me go to the previous slide. 1 second. Okay, yeah. So we saw that yeah, we divided our data. Okay, we divided our data here. Then we did a good level of EDA. Of course, I think around 40-50% time of R was spent on EDA only. That is what even is expected, that yeah, you will be making a lot of graphs and everything. Then we did the data preparation. So we prepared our data so that it can basically, we remove the outliers, we fill in the NA so that our data is basically full and models can be applied on top of that. And once we have all these things ready, is when we basically applied our models and saw the same. Few things can also be done in our data to increase the accuracy, to basically work smooth analysis. Okay, then let's say trying other algorithms, those things can be done. Kept that a little bit on an open end intentionally to make sure that yeah, you people are also spending it. It wouldn't have helped if I have increased the accuracy and you would have just seen me increase that accuracy. What I now suggest you to do is download this data set, download all these files. They should be available in, let's say, next couple of hours. Make sure that you are actually understanding what all I have done. Reach out to me, okay, on LinkedIn, or let's say comment in bottom of the video. I will make sure to answer all of the comments. Reach out to me and then make sure that you can add more to what we have done in this data. And once you are able to do that, try to increase accuracy and try to basically understand the concepts. This is a very, I would say, data which is a lot, I would say, representative of what we get in a healthcare industry or let's say in any industry. So if you are able to basically correct that, this will help you a lot. Okay, this can actually be a very good mini project, or let's say something which you can add into your CV also. So for people who always say that, hey, I don't have any project in CV, I don't understand ML, this full community class should be a very good stepping stone into that. I know few things were left, few things which you have used, they were not explained, but this kind of gives a little bit of you to curiosity to learn them on your own, and as well make sure that, so I will be taking other community classes on data science, DL, then let's say other unsupervised learning, as well as let's say on this PC and other techniques which we talked about, right? So will be making sure to cover all that. But till then, don't stop your learning. Work on this data, understand it, and make sure that you can, if you don't have any project, add that to your resume as well as to your overall understanding on how you understand the data. Okay, cool. So I think, yeah, this is all I have to cover for today. I know this become a little bit code heavy, but that is what case studies normally should be. And I know a lot of things might be still unclear, okay, because I have kept few things which were not explained in the community class, but if I would have done that, that would have been very easy to get. Okay, so just wanted to make sure that the level is a little bit above on what we have learned in the community class. You can still maybe leave the algorithm which we have applied, but all the other things which you have done in the previous three file, that is very important to understand. Model application, as you can see, is just very easy. You just have to basically divide your let's say define your model from the sklearn class. Normally that is what we do. Okay, I know still hyperparameter tuning and other things you still have to do, but yeah, this is what we have to do. So please just make sure that you're able to understand this. If anyone has any doubt, suggestion, feedback, anything, just please make sure that you are commenting that so we can cover that. We do have, yeah, good 5 minutes left. So just, yeah, add into comment and let me know if anything is there. I will meanwhile share all these files with the team so that you can get all this. Okay. And also, thanks a lot. I see a lot of people who joined again, basically, who were very regular in the classes. Okay, if you have any feedback, reach out to me. If you want to understand more, please reach out to me. If you have any doubts related to career, which you will want me to settle one on one or anything, check out other courses on our ineuron website as well. Okay, we are running a lot of community classes where excellent teachers are teaching on the concepts. Okay, so yeah, this was all for today class. Let me just write thank you as well. We will actually be back with the next week with another topic to cover in our community class. So yeah, if anyone has anything, please ask them in the comments, as I think we should be good to close our basically close our stream. Okay, I see people are dropping off, so should not sure if there are any comments or any feedback. So yeah, let me know if anything is there, everyone. Mohammed, so for this overall thing, the class, no classes tomorrow. I will be starting another community session that would be on different topic. Maybe I will pick up data science most probably. So we'll have that from next week most probably, but I will let you know. We will see that in the Neuron basically YouTube channel. So if you just go here, Neuron, so you can see here all the classes which will be happening. So if classes would be there, you can check out other classes as well. If anything would be there, you can just come here and see. Thomas, you can actually, yeah. So Sunny would be taking on the interview preparation series. You can basically start on that. Meanwhile, I will also be back with another class, and I will cover the concept as I have covered in ML class from deep within and with all the maths and everything. So it is very clear to you. Okay. Cool. Then, if nothing is there, I think we should be good to drop off. Thanks a lot, everyone, for joining and for your attention. We'll be sharing these files. Make sure to download them and basically play on them. So we'll actually be sharing files. These. Where is your notebook? Yeah. So all these files I will of course be sharing with all of you. So make sure that, yeah, you're able to understand this. Okay. Thanks a lot. Thanks a lot, Anand. Thank you, Thomas. It's really good to basically hear this. Of course, a lot of effort goes into preparing the material and everything. So we'll make sure to keep the same quality in other sessions which I will be taking. Okay. Sure, Anand. We'll be actually starting that next week, most probably. Along, like I have a course also, so with that. But yeah, we'll make sure that I am doing this community session and including most of the thing, so it is helpful to all of you. Okay. Cool then. Thanks a lot, everyone. Keep learning and yeah, just check out our other courses as well as on the website. Reach out to me if any issues regarding anything is there with respect to DS or ML. Okay. Thanks, Mohammed.